Hello everyone, in this video I want to introduce required softwares for numerical simulation of drug delivery in a human nasal cavity by a nasal spray device. Okay, this was my Master of Science thesis and I want to introduce required softwares. Okay, so I started from Mimix Software for extracting 3D geometry from CT scan images. Okay, as you can see here, this is CT scan images that I read them by Mimix Software. After that, we should extract the nasal airway from these images. Okay, in next step, we should determine air threshold in Mimix Software. For example, I select minus 1023 to minus 300 for air threshold for capturing air part of nasal cavity for numerical simulation. As you can see here, the entire air into the nasal cavity colored by blue. Okay, this is air and this is my domain for numerical simulation. After that, for split for splitting the geometry, I use Trimetic Software for better performance in this field. Okay, for example, this is maxillary sinus, or this is vestibule, or olfactory region is colored by yellow, and I done this work in Trimetic Software. It is good software for this target, okay, for this goal. After that, we should create mesh for numerical simulation, for fluid flow simulation and for particle deposition simulation. So for creating 3D mesh, I used ICEM software, actually Ansys ICEM CFD software for this goal. Okay, mesh created by Ansys ICEM CFD was on a structure because of the complexity of geometry, and I use the prism layers near the wall for capturing the boundary layer sharp gradients. Okay, after that I used Fluent software for numerical simulation of fluid flow and particle formation and deposition. Okay, in the first step of in Fluent software, I validated the spray model by the work of Entwine et al. 2012. Okay, as you can see, there is a cylindrical domain that nasal spray injected from upward and this is the droplet formation from nasal spray device. Okay, the diameter distribution is from 1 micrometer to 150. That is colored. You can see this contour colored by particle diameter. And for validation, I use Sutter mean diameter and volume mean diameter. That is okay. As we can see here, the validation isn't perfect, but it's sufficient for this goal, and it is good. I can't remember the maximum error in this validation, but it is good. It is good for this goal, and doesn't matter because of the nature of problem. Okay, the nature of simulation is very hard for capturing the exact results of experiment did by Intuan et al. 2012. Okay, it is good validation. Okay, you can see here type of mesh elements. For surface 2D mesh I use triangular elements, and for 3D I use tetrahedral, prism and pyramid elements. Okay, that I explained before. After that I do grid study for outer and inner geometry of nasal cavity, and I used 2 million cells for outer domain, and I use here 3.4 million cells for inner domain. It is appropriate mesh after I did grid study. Now you can see here the velocity contour of fluid flow and streamline. Here surgery. Okay, you can see here the entrance diameter of maxillary sinus increased after virtual surgery, and I want to see this effect on particle deposition in this sinus. Okay, and here the result of local and overall particle deposition is given here. Okay, the maxillary sinus has at least deposition percentage 0.01, but maybe it was good for this sinus. Okay, before and after virtual surgery you can see the maxillary sinus geometry here, and here the local deposition in this sinus. Okay, and finally this is the graphical deposition of spray droplets, nasal spray droplets in nasal cavity. And as you can see, the majority of particle deposited in the vestibule region, in the entrance region of nasal cavity, and just some particles deposited in olfactory region or other region. Okay. Thank you so much for your watching. Please don't forget to like this video and subscribe to my channel. Good luck.